Hi, I'm Karan Sheth, Technical Marketing Engineer with Cisco System, and in this video we will introduce Cisco battery control and measure its impact on iOS 7 mobile devices. We are all witnessing proliferation of mobile devices on our network. This device explosion has led to an increase in wireless service discovery and announcement protocols like Bonjour, DLNA, and Universal Plug and Play, which are all inherently multicast. Now, do you ever wonder why there is a drop in battery percentage of your mobile phone that was sitting idle for hours in your pocket? Guess what? One of the root causes for this drop in battery life is multicast traffic, which is broadcasted from every mobile device that is connecting to your network. This problem gets even worse in a high density environment. Every multicast packet in the air forces the host processor of the mobile device to wake up more often, thus causing higher battery consumption. But in reality, our Apple devices care only about Bonjour traffic, so why should they pay this extra tax on the battery? To address this challenge, Cisco is introducing battery control, which will leverage Directed Multicast Service or DMS that is part of 802.11v standard and which is now supported by Apple iOS 7 based devices. So let's take a quick look behind the scenes. An iOS 7 device before going off to sleep will register with Cisco wireless infrastructure using DMS exchange messages requesting the infrastructure to forward Bonjour multicast frames as unicast. In sharp contrast, no information is exchanged between the infrastructure and iOS 6 mobile device before it goes off to sleep due to lack of DMS support. On an arrival of a multicast packet, our iOS 7 device will periodically wake up every 90 seconds and process only unicast Bonjour frames that are converted by the infrastructure. On the other hand, iOS 6 is forced to wake up every 100 milliseconds to process every multicast frame in the air. This results in higher battery consumption for iOS 6 device when compared to iOS 7 device with support of Cisco's battery control. On taking a close look at the device wake-up timetable, we can see that with the current power savings technique, our iDevices have to wake up every 100 milliseconds to process multicast frame. But with Cisco battery control, our iDevices can sleep as long as 90 seconds because the infrastructure converts these multicast frames to unicast for the iDevices to process. Our testing with iOS 7 resulted in a 50% of battery savings with Cisco battery control when a single multicast packet is broadcasted every second over a period of 4 hours. So now imagine with these savings all the additional time you have for an awesome mobile experience. Thank you for watching.